In this video, we will learn about supervised and unsupervised learning, focusing on predicting a class or a number with supervised learning, anomaly detection, clustering, and dimensionality reduction. First, let's look at the image. We start by predicting a class, and since we are talking about technical analysis, the class is whether the change will be up or down tomorrow. Given that this is a classification between two possibilities or classes, up and down, we use a classifier. A typical supervised learning algorithm, we train the model with examples, but what we want is to make predictions for future cases. Instead of predicting the change percentage, which are the two classes or possibilities, up and down, we might want to predict the magnitude of the change. In this case, it is a number, and therefore, since we have examples to train with, the algorithm will be supervised learning and regression. Similarly, with this model, in the absence of exact mathematical formulas and statistics that can handle it, we aim to predict the change that Boeing, Chevron, or Coca-Cola will show tomorrow. However, predicting in such absolute terms is not a realistic goal, given that in markets, there's little signal compared to noise. Therefore, we will seek more appropriate goals. For example, one of the significant problems faced by the technical analyst is the break of critical levels, such as a support level, as sometimes they are noise or false breaks, whipsaw. Let's see how the price can approach a support level. 1. A direct and clean break. 2. Minimal consolidation before breaking. 3. A longer but still temporary consolidation before breaking the support. 4. The break does not occur. The price cleanly supports at the level and then rises. However, reality is not as clear as in books, and our duty in the course is to explain how to obtain and increase the signal or information without creating unrealistic expectations. Markets often move with many noises or whipsaws, so besides a possible clear and direct break, we could encounter the other three possibilities but with noise. That is, it seems to break the support at first, but in reality, it doesn't break until later or even never does, potentially leading us to execute an unnecessary stop loss. If we can train a model to help us differentiate when the break is real and when it is noise, we will increase our chances as technical analysts. Let's make a parenthesis and remember that we're working at this point with classic learning, with labeled examples, that is, supervised learning, where we can predict numbers with regression models, or classes with classification models. How would this be more concretely? An example of regression would be predicting the return of a stock for tomorrow, and an example of classification would be predicting whether it will go up or down. Any technical analyst has found themselves in this situation where the price might be breaking a critical level. In this case, instead of support, it is a trend line. There are only two possibilities. It is noise, which could lead us to close the long position unnecessarily, or it is not noise, and the upward trend has ended, in which case we would want to close the position. Distinguishing whether it is noise or not is therefore fundamental.
Is the German DAX index price breaking the trend line, or is it a noise?
Look at the volume. Volume can help.
Do you have a formula?
Of course not.
Do you mean this is more like an art?
Maybe in the past. Now we have machine learning models.
Let's continue exploring these concepts. Regression involves predicting a number, and therefore, we would use these algorithms to predict today's closing price. A regression algorithm would also work to train a model that assigns a probability of success or trend reversal to a candlestick pattern like a hammer. So, not all hammers work the same. A hammer, on average, reverses the price upwards approximately 60% of the time, but it is very interesting to use models to adjust the probability of each specific hammer. Now we see classification, where we choose between specific possibilities. We have already seen the case of training a model to distinguish between noises and real breaks. Also, with a classifier, we can decide if a head and shoulders pattern is reliable or not. Similarly, we can create countless models, which the academic world does not value but are appreciated in the field of technical analysis. In areas like Ichimoku, Elliott, indicators, etc. Thus, we can easily train a model that will also work very well to recognize what type of correction within Elliott's possibilities has presented itself. Anomaly detection is a fascinating field that can be performed with supervised or unsupervised algorithms. Depending on the objectives, we all know the frequent anomalies that can occur in the markets, sometimes real and other times due to data corruption. Training models with anomalies is not a good idea, so detecting and processing them is fundamental. Regarding unsupervised learning, we do not have a specific objective. There is no column we want to predict and give examples of, but we simply provide the prediction data we call features. What interest can predictive data have if there is no prediction to be made? Let's focus on the data we have calculated, specifically moving averages, RSI, and ATR. Clustering is one of the answers. Depending on the combination of indicators, we can create similar groups, such as in this case, Cluster 1, Cluster 2, or Cluster 3, each with its similar companies. Another use case for unsupervised learning is dimensionality reduction. That is, reducing the amount of data we use. Now, if we have a column of data that is the 20-unit session moving average and we remove it, we do have fewer data, but it is not through a machine learning dimensionality reduction algorithm, but rather by merely deleting that feature, which would be part of the feature selection process. Dimensionality reduction refers to the hybridization of two or more features or columns into one. For example, suppose we have the 14-session RSI and the 14-session ATR, and they are strongly correlated. We could convert them into a single indicator, a single column being a hybrid of RSI and ATR.